Working with the unit review, I do want to work out a few of the questions that I find a little bit more challenging. So I think there's about 9 of these altogether, maybe. So let's look at question 1. It's actually an application that you will probably see on your exam. So a ball is thrown vertically upward from the top of a building 120 feet tall with an initial velocity of 112 feet per second. The distance s in feet of the ball from the ground after t seconds is given by the equation s equals 128 plus 112 t minus t squared. After how many seconds does the ball strike the ground? So in this problem, they gave us the equation that we want to use, but to make sure we understand this equation, it's not a bad idea just to draw the picture of the drawing here. So we have a building. So that's my building. And there's a ball that's going to be thrown vertically from the top of the building. But notice that the building is actually 128 feet tall. So the ball to start with is 128 feet off the ground and it's thrown vertically. Now remember, when it's thrown vertically, it's going to be thrown upward, but the path of the ball kind of goes up and then gravity pulls on it and it's going to turn and go down. So something like this. So the ground is down here. We'll use this as our ground. So this is the path of the ball here. So it kind of makes something like this. So the question is, how many seconds does the ball strike the ground? So right now, we know in 0 seconds the ball is here. What we know is we want to know what the time is when the ball is down here at the bottom on the ground. Now, for me, what I want to do is rewrite this equation the other direction. So I'm going to rewrite this as negative 16t squared plus 112t plus 128 is equal to s. Now they're asking for how many seconds does the ball strike the ground. So to do that, we're looking for t. But to solve for t, we need to know what s is. Well, if the ball is on the ground, that means how far above the ground we are is, well, we're not above the ground, we're on the ground. So that means the height is actually simply 0. So to solve a, our equation becomes negative 16t squared plus 112t plus 128, and the height off the ground is actually 0 feet, if you will. So the s gets replaced with the 0. So we have a quadratic equation. Now, to make this a little bit easier, I'm kind of curious, does the 112 and the 128, are those divisible by this negative 16, or 16, if you will? So I'm going to go on my calculator. 112 divided by 16, does it go into it evenly? It goes into 7 times. The other thing is 128 also divisible by 12, by 16? And it also gives me an answer of 8. So what this tells me I'm allowed to do is I can make this equation a little bit more easier to deal with if I just divide everything by negative 16. So you also have to divide their side by negative 16 as well. So notice how the negative 16s will divide out and give me this t squared. 112 divided by 16 was 7, so 112 divided by negative 16 is going to make that a minus 7t. And 128 divided by negative 16 is going to be then this minus 8, and that's going to equal 0. So the question is, how do we solve this equation? Well, since it's quadratic, we want to kind of start with maybe factoring. Since the quadratic term is t squared, we know we can set up two sets of parentheses, and we know that t has to go here and here. Now, the catch is the factors of a negative 8 must add up to equal the linear coefficient, which is the negative 7. So the factors of an 8 are 1 and 8 and 2 and 4. 3 doesn't work, and then 4 and 2 is just repeating. So we really only have two pairs. Which one of those pairs has the ability to give me this negative 7? Well, to get a negative 7, we have to also observe that we have to get a negative 8. To get a negative 8, one of these factors has got to be negative. To get a -7, that means the bigger factor is going to have to be negative. So I'm looking at this 1 and -8 and this 2 and -4. What jumps out at me is 1 times -8 is -8. 1 plus -8 is -7. So this tells me this problem is factorable. So I can write this as then t minus 1, actually t plus 1, and then t minus 8 is equal to 0. Now, to solve a quadratic equation by factoring, one of these factors has got to be 0. So either t plus 1 has to equal 0 or t minus 8 has to equal 0. Well, if I solve these equations, we pick up on t is equal to -1 and t is equal to 8. Now remember, this is a word problem. T represents time in seconds. Well, -1 would not be reasonable. You can't have -1 seconds. So our time becomes then 8 seconds. So 8 seconds becomes our solution. So what we're saying is then, if I look at this picture, this ball is thrown, and when it hits the ground, 8 seconds would have elapsed. So at that point, we're back on the ground. Now, part B says, how many seconds will the ball pass the top of the building on its way down? So what this question is saying is, you're starting here with the ball, it's going up, and then it's going down. And notice how at this point here, it's going to be passing back by the height of the building. So this is the time in question is, what's the time when I'm here, passing back by the building on its way down? Well, notice that the height off the ground this time is actually going to be the height of the building, which is 128. So to do part B, we're going to use the same equation. We're going to have this -16t squared plus this 112t plus 128. But this time, the height off the ground is not 0. The height off the ground is actually 128. Now, to solve this quadratic equation, we have to set it equal to 0. So if I subtract 128 on both sides, our equation turns into -16t squared plus 112t is equal to 0. Now, if I divide everything by -16, we're going to end up with then t squared, and then 112 divided by 16 was a 7. So 112 divided by -16 is going to be the -7, so that's going to be a -7t, and then 0 divided by -16 is still just 0. Now notice that this problem is factorable. These two terms have a t in common, so I can factor this as t times then t minus 7 is equal to 0. So it is factorable. Now, t is a factor and t minus 7 is a factor. To get equal to 0, one of these factors has got to equal 0. So either t has to equal 0 or t minus 7 has to equal 0. Well, t equals 0, that's already solved. But if I solve this one, I'm going to get t equals 7. So notice that 0 is when we're on the building. What they want to know is when we're passing back by the building. So that means we would reject the 0 as the answer here because that's on the building. The 7 seconds is going to be the answer to this problem. So 7 seconds is when we're passing back by the building on the way down. So 7 will become the solution to that problem. So that's kind of how we approach that word problem.